All right, everyone. Today we're working on section 2.3, derivative rules and concepts. By the end of this lesson, you should be comfortable finding derivatives using basic rules like the power rule, the constant rule, and rules for radicals, logs, and exponentials. One important idea to keep in mind today is that a lot of derivatives become easier when we rewrite expressions using exponents. You'll see that come up multiple times in the examples we're about to look at. This is going to be all the rules we have. The power rule is when an exponent is going to be, when the exponent is applied, you subtract 1 from the exponent, you multiply the exponent to the main number, and then you subtract 1 from the exponent, and that's going to be your derivative for that one. And then we have special cases for a constant number. It'll just automatically become 0, and if a number is multiplied by just x, no exponent, it just the x equals 1. And then we have exponential functions like e of x, e to the x just equals e to the x. And then we can move on to problem 1. Have y equals 2x squared minus 3x plus 4 over x squared. Now we can rewrite this a little bit easier, so it's easier to take the derivative of it. We could do y equals 2x squared minus 3x plus 4x to the negative 2 power. So when you move an exponent up from the denominator to numerator, the exponent becomes a negative, but this is easier to take the derivative out of, so it's simpler to do. So now we could do the derivative. We could do 2 times 2 right here, and this 2 would be minus 1, so it becomes 4x. And then right here we have 3x. Since x just equals 1, 3 times 1 just be 3, so this derivative is now negative 3. And then we have another product rule right here. We have negative 2 times 4, which equals negative 8, should be negative. And then it would be minus 1 to the negative 2, which would be 8x to the negative third power. It should be negative 8x to the negative third power. And then since it's negative 3 up top, we move that back down to the denominator, and that's going to be x to the third right there, as you can see. Yeah, don't mind that. That should be negative right here because you multiplied that by negative 2. It's just a mistake I made. Then we go to problem number 2. We have y equals 3 multiplied by the square root of x minus 4 over the cube root of x. So we could make this a little simpler to read. We could do y equals 3x to the power of 1/2 minus 4x to the power of negative 1/3. So since the cube root right here, it would just, in the square root and the cube root, is just 1 and 2. So 1/2 is the square root and 1/3 is a cube root. But since we move this one up from the denominator, it becomes a negative. So negative 4x to the negative 1/3 power. And same thing that we did in the last problem, makes it a lot easier to get the derivative. So we multiply 3 by 1/2, so we get 3/2 x. We have to now subtract 1 from this exponent, so that 1/2 becomes negative 1/2. And the same thing on this side, multiply negative 4 by negative 1/3, that becomes positive 4/3, multiplied by x, subtract 1 from the exponent, negative 4/3, and then you simplify this a little bit more, so we can move everything back down, become square roots again, and become cube roots again at the bottom with exponents and everything. So the 3/2 times x to the negative 1/2 becomes 3 over 2 times square root of x, plus, same thing over here, 4 over 3 times the cube root of x to the 4th power. Now we have problem number 3. This one's going to be a little bit longer, a little bit more lengthy, but should still be the same process. Instead of using the quotient rule, we simplify first by rewriting square root of x as x to the 1/2, and then moving it up so it's x to the negative 1/2, and then we distribute that x to the negative 1/2 to every expression inside of here. So 2x to the third times x to the negative 1/2 equals 2x to the 5/2, and then 3x squared times x to the negative 1/2 equals negative 3x to the 3/2 power. Same thing with the 5. Just a little bit easier since it's just a constant. We could do 5x to the negative 1/2. Then we could take the derivative of this function, and it becomes 5x to the 3/2, because you multiply this 5/2 times 2, that becomes 5, and then you subtract 1, so it becomes 3/2. Same thing on this side. 3 times 3/2 equals 9/2, and then subtract 1 from the exponent, becomes x to the 1/2. Same thing on the third expression. We could do negative 5 times negative 1/2 becomes negative 5/2, x to the negative 3/2. Right here, we don't have to simplify this one technically. You could if you wanted to. You don't have to, because there is a lot going on, mostly with the fractions right here already and all of that. And then we can move on to problem number 4 now. And this one's going to be a lot simpler. It's just going to use the logarithmic and the exponential function right here. So it's simple. It's very easy derivative. This is probably the easiest rule. The logarithm rule, 3 times the log of x, just move the x to the denominator and keep the 3 at the top. Very simple. And then e of x stays e of x all the time, and you keep that constant right there as well. So it just becomes 3 log of x minus 5 e to the x becomes 3 over x minus 5 e to the x. And then to wrap up everything today, the big ideas were we were able to rewrite radicals and fractions using exponents. We were able to apply the power rule term by term, and then we were able to simplify expressions before choosing more advanced rules, and to know your basic derivatives for log of x and e to the x. If you practice these steps consistently, derivative problems will start to feel much more manageable.